Hello, this is Mr. Win, and this video is graphing quadratics. Hopefully you know a quadratic function is an equation where the greatest exponent for a variable is 2. F of x equals ax squared plus bx plus c is a very common form. It's called standard form. And each term has a name depending on the variable and its exponent. So ax squared is the quadratic term because it has x squared. Bx is the linear term because it has x to the first power. And c is the constant term because it has no x. And remember, a can never be 0. Because then it would be quadratic, could be linear or constant. B and C can. The graph of quadratic is a parabola where the shape is pretty much like a U, and all the order pairs make the equation or function true. And notice that the A here in ax squared plus bx plus c is the same A we use when graphing using AHK transformations. So A will tell you if it's vertically stretched, vertically compressed, reflected over x or not. Alright, so to graph an equation in standard form, we have to find 4 things. First, we find the y-intercept. The y-intercept you find by plugging in 0 for x. But when you do that, the ax squared term, bx term goes away, and it's just c. So you always know c is the y-intercept, no work needed. The second thing is the equation for the axis of symmetry is x equals negative b over 2a. It's this red line right here. It's also sometimes called the line of reflection, but it's where we can pretty much fold the parabola in half and it'll overlap perfectly. Then we can find the vertex. The x-coordinate of the vertex is always on the axis of symmetry. So if you have this line, the vertex is somewhere on there. In this case, it's right here. So the x part of that vertex is still negative b over 2a. And once you know the x value, you plug it in to find the y value. And sometimes they show the vertex as this. It'll be negative b over 2a as x. And then when you plug in for y, that means f of negative b over 2a. You get your coordinate. And the last thing is the y-intercept reflection over the axis of symmetry. So everything on the left side is the same distance from the right side for the axis of symmetry. So if I have this point right here and say this is like 5 spaces, then this would also be 5 spaces away. So you can always find this. You leave the y the same, you just change the x. Alright, one last slide of information. So the y-coordinate of the vertex is also called the maximum or minimum value of the function depending on the sign of a. If a is positive, the u is going up. We're not flipping it upside down, so we have a bottom or minimum point. And the y value of that, of the y-coordinate of the vertex is called the value, the minimum value. If a is negative, that means our picture is flipped upside down or reflected over x-axis. That means our u will have a maximum point. Again, the y-coordinate of the vertex is the maximum value. Sometimes they ask for the location. The location is just x-coordinate. So the x part of the vertex is the location. The y part is always the value. And the last thing is the solutions of a quadratic function are the x-intercepts. These are also called zeros and roots. In a quadratic equation, you have 1 real solution, 2 real solutions, or no real solutions. So looking at these 3 pictures real fast, this first one has 1 x-intercept, so it has 1 root, 1 real root. The second one has 2 x-intercepts, so it has 2 real roots, 2 real solutions. The last one has no x-intercepts, so we say no real solutions because they're going to be imaginary. Alright, so let's do a problem. It says graph the quadratic function, state whether it has a max or min value and identify it, state the number of solutions it has, and then do domain and range. So this equation is in standard form. It has ax squared plus bx plus c. So first I want to find is the y-intercept. Well, I know the y-intercept is c, so I know it's going to be 0, negative 4. So that's done. The next I'm going to find is the axis of symmetry. We're going to abbreviate as AOS. That's going to be x equals negative b over 2a. Make sure you know a, b, and r. So here's a is negative 3, b is positive 6, c is negative 4. So I plug that in, negative b, negative 6 over 2 times a is negative 3. That's negative 6 over negative 6, which is positive 1. So we know x equals positive 1 to axis of symmetry. Then we have to find our vertex. We know the x is 1, we have to find the y. To find the y, you plug in that 1 into the equation. So I'm going to do negative 3 times 1 squared plus 6 times 1 minus 4. Do the x1 first. Negative 3, 1 squared is still 1. Plus 6 minus 4. That's negative 3 plus 6 minus 4. That's positive 3 minus 4, that's negative 1. Alright, with that I can actually graph the picture. So let's graph the points we know. we know we have the y-intercept is 0, -4. So 0, 1, 2, 3, 4. So that is 0, -4. Then we have axis symmetry. X equals 1. I'm going to draw a dotted line there. Alright. Now our vertex is on there. We have 1, -1. So right here, this is our vertex. That's 1, -1. Now our vertex, well, we'll reflect the point axis symmetry, the y-intercept over axis symmetry. So if this is 1 away from axis symmetry, so I'm going to go 1 over towards the line, do 1 over again. That's our reflected point. So it went over twice, 2. So that's 2, -4. Our u will be this. Now my u is upside down, and should it be upside down? Because a is negative, the picture is flipped. So yes, this picture is correct. Because it's upside down, we have a minimum. Sorry, a maximum. So we have a max, and it's a value of -1. So let me see. We graphed it. We said it has a max. We found the value, which is -1. What else? It says state the number of solutions. I'm looking for number of x-intercepts. I don't see any, so I'll say no real solutions. Or you can say no real roots. They're both imaginary. Last question is find domain and range. So domain never changes. Domain is how far left does the graph go, how far right does the graph go. So the u goes left forever, no infinity, goes right forever, positive infinity, or all real numbers. The range is low to high, it goes down forever. It goes up all the way to -1, that's closed. And you can say or y is less than or equal to -1. Alright, and that's it for this first problem. So we graphed it, we found the y-intercept, axis symmetry, vertex, use that vertex as the maximum or min value. I'll say this, the vertex is located at x equals 1 and has a maximum value of -1. So that's how you say the x and the y. No x-intercepts, so no real solutions, and then that's the domain range. Alright, you can also graph a quadratic equation in vertex form. Looks like that, y equals the AHK. So this is the same AHK transformation form we learned before. It's easier and less work than standard form. So A does the same thing, vertically stretch or vertically compress, always by a positive number. The negative in front reflects the graph over the x-axis. We say flip, upside down. A shifted left to right, but it's opposite. K is up and down, but it's normal. And now I'm going to tell you h comma k is called the vertex. And remember, h is opposite and k is normal. So this is called vertex form because we can pull the vertex out of the equation. So same thing, graph, say what is max or min, identify it, say the number of zeros, x-intercepts, and domain range. So this is AHK form. I mean, we could do what we did before. The type is y form, so we say it's quadratic. It's a U shape. It's vertically stretched by +5. It moves right 3 and it goes up 2. So if I go from 0, 0, I go right 3 up 2. I put a dot here. So that's 3, 2. I draw a U, but my U is vertically stretched, it's skinnier. Alright, so there's my picture. I can answer other questions. There's a max or min. It has a minimum because the U is going up. There's a bottom and no top. So minimum value of 2. And the minimum is located at x equals 3, but the minimum has a value of 2. See the number of zeros it has? There are no real roots, no x-intercepts, so no real roots. You say no zeros. And the 0 is where y equals 0, because all x-intercepts have a y value of 0. Is to state the domain and range. Domain, how far left? All u's go left forever, right forever, or all numbers. Range, lowest is +2, closed. Highest is infinity. Or y is 2 greater than or equal to 2. Alright, now I didn't ask for it, but we could also find the axis symmetry. Remember, the vertex goes through the axis symmetry, is a point on the axis symmetry. So even though the vertex is x, well, is 3, 2. We also know that the axis symmetry, even though we don't have the negative v over 2a, is x equals 3. It'd be this dotted line. So if you know one, you should be able to find the other, in case we wanted it. Now the y-intercept is somewhere way up there. To find the y-intercept, you can actually plug in 0 for x and just simplify, and you'll get the y-intercept. In the last slide, the location principle for zeros. So if you're given a table of points, you should find the obvious solutions or be able to approximate the location of them. It's the common sense fact where you see if you have start at some negative number for y and then you later get a positive number for y, you had to cross through 0. Same for reverse. If you start positive number and it turns negative, you had to cross through 0. Again, we're covering the y. So the easy way to look for this is to see where the y value changes signs from negative to positive or positive to negative. You can also plot the points and see where they are. So down here, here's the table where the root's located. Now check for the obvious roots first. Remember, root is the x-intercept. X-intercepts have a y value of 0. Are there any zeros for y? Answer is no. A lot of kids see the 0 for x, and I think that's the answer, and it's not. So there's no obvious ones. We're going to look at the sign change. So this y was negative, this y is negative, then turned positive. Right there is a change in signs from negative to positive. So let me graph this real fast and show you. If I graph the first thing, say -6, -9, it'd be left 6, down 9, somewhere down here, -5, -2, somewhere over here, then -4, 4 is up here. But I had to go up, I had to cross through 0 right here, wherever this is. So I know between -5 and -4 for x is my root. Alright, so I could do the whole thing and see where it went high or low, or across the x-axis. So anyways, it goes negative, negative, positive, so there's my first change. Then it goes positive, 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 negative, so there's my second change. It goes negative, negative. Alright, so there's a root there and a root there. So we'll say it's located, you gotta say between, and when the location is always the x, the value is the y. So we're going to say x equals -5 and x equals -4 for the first one. The second one is x equals -2 and x equals -1 for the second one. And this works for any type of graph. It doesn't have to be quadratic. So there could be 3 roots, 4 roots, 5 roots later on in the year. But again, which is the y sign change. And that's it. Hope you enjoyed the video. Make sure you ask questions class. See you soon. Thanks again. Bye.